Today, the next voted one was the wave theory. So as I said in the Facebook group, we're going to try and sort of split it into like 5 different bits. How waves are made, how and why they break when they reach our shores, why they break in different shapes on different beaches, go a little bit over like what swell period is and what that does to waves, and also the difference between ground swell and wind chop, which are 2 sort of surfing terms related to waves that you might or might not have heard. This surf theory thing is where like the sciencey side of surfing and those principles, they can get pretty complex. So I'm going to try my best not to get too in depth with it, just give you guys like a basic overview on all of it. If anyone's got any bits that they're more interested in, I can try go into more detail. And also I can let you guys know where to find more detail if you just want to sort of, you're interested in the subject and you want to know more. Same as I said last week though, everything in surfing, all the things we're going to discuss are caused by so many different factors that means there are exceptions to almost every rule and every fact that I tell you guys. What we're aiming for with all of these sessions is not to sort of give you guys the be all and end all, this is how it is, just to give sort of a basic understanding of what happens and why. So if we start off with like how waves are made, we covered this with a few of you. Sophie, I know you were there. Adeline was there when we were up at Sea Bay back in January. So I won't spend too long on this first bit. Dawn, were you? I can't remember if you were there with us.
No, I don't think I was, but I've done a little bit of theory stuff before. So
okay, cool. Well, if there's anything at the end, if there's anything that you didn't quite get, then just give me a shout and we can go over it. But just to go over the basics of that again to refresh everyone. Basically, out in the ocean, wind blows over the surface of the ocean. That transfers energy into the water, causing waves. You guys can see the easy way to see it is if you fill a sink with water and blow on it, watch a pond or a lake when there's a bit of a breeze, it's more or less that same process. You can see that as the wind blows, ripples start to happen and they sort of work their way across either the sink or the lake or the pond or whatever it is. It's just out in the ocean, it happens on a much bigger scale. If there's no wind at all, the ocean can be flat and calm. If it's been howling for days, we can have a fully like really risen sea state with huge waves and everything in between. But there are basically 3 main elements that decide how big the waves are as they're being created there. There's the speed of the wind that's blowing on the water. There's the length of time that wind is blowing for, so like how long the storm lasts. And then there's the distance over which that wind is blowing. Now that last point is probably the one that's the more difficult concept to understand. So I'll just explain that a bit more. Imagine, right, we're going to go deep in the analogies now. Imagine like a long rectangular pond. Okay, we've got a big fan at one end that is slowly just moves across the water. Okay, so it's going from one end all the way up to the other. Now along either side of that, you're still going to get waves. You're going to see smaller waves there. It's not that they're completely unaffected, but at the far end of the pond where that fan has basically been following the waves all the way along, that's where you're going to find the biggest waves. So that's that concept of like the distance over which the wind is blowing on the waves. Essentially out in the ocean, way that works is if the storm is moving in the same direction as the waves that are traveling towards our shores. So the speed that the wind's blowing, the length of time that the storm lasts, and then how long both the waves and the storm are moving in the same direction. They're the 3 things that are basically going to allow the waves to take on more energy, get bigger and get more powerful. Now, once we get into breaking, I'm sure you guys already know that waves break when they reach shallow water. For now, I'll come on to it later, but for now, we're going to ignore the differences in different shapes of waves and just go through like the basic principles of what happens as a wave breaks. Anyone who wants to know exactly what's happening, remind me at the end and I can recommend a really, really good book that explains all the like scientific principles behind it. But for now, we're just going to say that basically as waves enter shallower water, they slow down. The speed that a wave moves at is directly linked to the depth of water that it's moving through. So out in the middle of the ocean, the differences in depth between the bottom of a wave and the top of the wave are really kind of negligible when you compare it to the massive amount of water it's in. So for example, if we're talking about a 1 meter high wave, but it's in a kilometer of water, that means the bottom of the wave is at 1,000 meters. The top of the wave is at 1,001 meters. So that's such a small difference in that scale of numbers that we're talking about that it's irrelevant and the waves just move through deep water with very little effect. As the wave reaches shallower water, let's say we get it down to like 2 meters of water as it's coming nearer the coast, that difference between the top and the bottom of the wave is much more important. So let's say in 2 meters of water, the bottom of the wave is at 2 meters from the bottom, the top of the wave is at 3 meters. So that's suddenly a 50% difference in the depth of water between the top of a wave and the bottom of a wave. The reason why that's so key, going back to what we mentioned before, is that waves slow down as they're in shallower water. As they're in shallower and shallower water, they get slower and slower. So given that the bottom part of the wave is technically in shallower water than the top part of the wave, it creates that imbalance. It means that the bottom of the wave is traveling slower than the top of the wave. Is everyone sort of with me so far?
Yeah.
Cool.
Yeah.
So as it continues into that shallower and shallower water, this bottom part of the wave here slows down and slows down until it reaches a point where the top of the wave basically overtakes the bottom and it spills over onto itself and breaks. Think of it as like the wave essentially getting tripped up. In the same way you would imagine if you're going along and suddenly your head is traveling faster than your feet, you're eventually going to fall over. And that is pretty much what happens to the wave as it reaches shallow water. If all beaches were the same steepness, that would be it. Waves reach shallow water, bottom slows down, top doesn't, wave breaks, we surf it. The bit that Adeline, I think, was asking about on the Facebook group is that sort of difference between why waves break in different shapes, and more specifically about why some waves barrel and other waves don't. The reason there can be so much variation is that a major factor in deciding how a wave breaks depends on the speed that the bottom slows down compared to the top. And that is directly influenced by the shape of the ocean floor, wherever that wave is breaking. You'll hear people talking about it as beach shape, beach profile, or if you really fancy terms, the topography of the beach. But basically, it's how steep the beach is, which is going to cause the bottom of the wave to slow down and let the top of the wave carry on. The speed at which that happens determines what happens with the wave. So if we, first of all, we take the example of a really gently sloping beach. If you're looking across it to the naked eye, it's pretty much flat. The bottom of that wave is going to slow down at a much more reduced rate. So it means the wave is going to reach that toppling point where the top and the bottom are kind of lined up at a much slower rate. It's going to gradually come up here. Once gravity takes over and that can't hold itself up, the top's going to gradually crumble and spill there. In essence, it's going to be a much sort of friendlier looking wave, crumbly wave, or what in scientific terms, in surfing terms, you quite often call it a spilling wave. It's basically one that's going to come up, it's going to reach that critical point, and the top's going to slowly start to crumble. Anyone who surfed Poles F, the classic sort of spilling wave, Cranbrook at high tide or mid tide does the same. Where it comes in, it never gets super hollow, it just sort of crumbles through. So that's what happens on a really sort of shallow sloping beach. In comparison to that, let's compare that with something like a reef offshore that sits in really deep water, something like Pipeline in Hawaii or Chopu out in Tahiti. It goes from really super deep ocean to suddenly there's this slab of rock there where your wave's coming in and it hits that. What happens is the whole wave travels in from deep water at really big speed, really high speed. All of a sudden, the bottom of the wave hits the brakes. So that bit of the wave stops and it causes the top to sort of suddenly throw out. And that's what gives you your steep, hollow wave shape. Okay. So anything that's a bit of a steeper beach, it means the bottom slows down much quicker. That bottom slows down. And instead of the top of the wave reaching this point and crumbling, it's still got so much momentum that it actually throws over and breaks into that barreling shape. Is that kind of, is everyone still with it?
Yeah.
Cool.
So, yeah.
So that's all one major factor. However, as I said, with everything, it's not the whole story. And that kind of leads us quite nicely onto the next part, which is about the swell period and what that does with waves. So we're going to go back now to when waves are first created. Swell period is basically the time in seconds between two waves. I'm sure you guys have seen it on Magic Seaweed where it says 5 foot at 10 seconds or whatever it is. Explaining it and what it actually does to waves is unfortunately a little bit more complicated. So if we go back to that first bit, in the middle of a storm, there's lots of waves constantly being created as that storm and the wind blows over the surface of the ocean. There's some waves that absorb more of the energy, so they're bigger. There's others that are either newer or haven't absorbed as much of that wind energy, so they're smaller. And new waves are constantly being created for as long as that storm system is swirling around. Now, the speed that a wave travels through deep water is all dependent on its wavelength. Now, it's kind of a similar measurement to the wave period, but it's the distance in meters between two waves. The longer that wavelength, so the longer the distance between two waves, the faster the wave is moving. Okay, and hence the more power, generally the bigger the wave. If we use another little analogy, and instead of waves, we're thinking about marathon runners. Okay, we're going to have some marathon runners in this little scenario that some of them are 7 foot tall, huge, long, lanky legs, really big stride. And there's others that they're racing with that are like tiny little 3 foot people, and they've got tiny little dumpy legs, and with everything in between there. All right, I'm trying not to get too offensive here. So let's say they're all on this big long line, huge range of people, different size, different length legs, different strides. They all set off from the start line at the same time. If you take a snapshot of them 1 meter from that line, everyone's going to be all jumbled up. Okay, you're going to see the smaller legged people and the long legged people all in together. After a few 100 meters, you're going to see a lot of those sort of lankier, long-legged Mac Daddies taking their big, long strides. They're going to be way out in front, okay? The more sort of vertically challenged people are going to be further at the back with their little legs trying to keep up. If you then looked at them a mile after that, that spread would be a lot more exaggerated. After 10 miles, there'd be a real huge separation between those that can take the longer strides and hence go faster, or the ones with the shorter legs that are having to sort of scurry along behind. Now, if we flick that back over to the waves, those bigger waves with the longer wavelengths traveling much faster are eventually going to separate themselves from that pack of the sort of more turbulent, stormy waves as they travel over bigger distances. And swell period is basically related to that. If the waves have traveled further from that main storm system to reach our shores, they're going to be more spread out, they're going to be more organized, and that's where we get that bigger period, that bigger time in seconds. If we're closer to the source of the wave, so the storm's sitting just offshore or right on top of us, that's when we get those sessions where the waves are all mixed up. There's a lower average wave period. It's not to say that there won't also be the big waves in the middle of that mix. It's just they'll all be jumbled up. There'll be a load of small waves. There'll be a load of big waves. There'll be a load of little short-legged. Oh, no, not short legs anymore. We'll flip back into it now. So for us as surfers, that more cleaner, sort of more organized swell with the longer period generally means it's better wave condition for us. The waves are easier to read. For the size, they've got a bit more push, a bit more power to them. That bigger wavelength means they're moving quicker. And that's why that longer period swell is more sought after. Another element, bringing it back to wave breaking, is that those longer period waves are traveling faster. Okay, because they've got the longer wavelength, they're traveling a lot faster through the ocean. That means when they hit the shallow water, the difference in speed between the top of the wave, which is still traveling at that sort of deep ocean speed, compared to the bottom of the wave, which is suddenly slowing down, that difference in speed has got the potential to be a lot bigger. So those waves hitting the bottom, that means those faster moving, long period swells are a lot more likely to form steeper barreling waves than that shorter period swell is. So if you see, you know, sometimes we get that really small but really long period swell that's only 2 foot, something like that. It's about waist high. As that's coming in, you can still see sometimes that even those little waves are there barreling. And that's just because of the speed that they're traveling in at. They've got that longer wavelength, longer period swell, a lot more sought after for us as surfers, really. Now, I hope I haven't lost you guys. I did worry it was going to be pretty, there's a lot of different concepts all sort of working together here. But the final part is that difference between ground swell and the wind chop. It's two terms that you guys have probably heard us use to sort of describe wave. Oh, it's all a bit wind choppy. Oh, this really nice ground swell coming in. Luckily, those two terms are basically just different ways of talking about what we've already covered. So ground swell is simply another term for those fast-moving, long-period waves that we've talked about. Think about like that picture postcard swells where you've got long, clean lines all the way to the horizon. That's a ground swell. That's those long wavelength, long period waves that have come from a storm miles out to sea, and they've had time to organize themselves as they get closer to us. Wind chop, on the other hand, is that picture of the start of the marathon, where all the big waves and small waves are all jumbled up. There's no way to differentiate between them. You wouldn't be able to pick which one was coming. The average period then is super low, so the swell hasn't had time to sort itself out. Yes, on those windy, choppy days, there are still some good waves in there. There's still decent waves in there if you search hard enough. But generally, the swell is all going to be pretty gutless. It's hard to predict when and where the waves are going to be coming from, and there doesn't seem to be very much pattern to it. So that is kind of very, very super quick. That was the brief overview of quite a lot of technical and sometimes difficult to understand concepts. I really hope I managed to get it across so that I didn't lose any of you in there. If I did, I didn't blame you. Those sort of concepts. Oh, that's good. That's good. When I was in uni, like we were studying oceanography, and we covered all of those points in a lot more detail, granted, but it was over the period of a few months, gradually trying to build up the levels of understanding one on top of the other. So I've really tried to try and do that in like half an hour is always going to be pretty tricky. We've also skipped in there a lot of other factors that can go into how a wave breaks. Some of those we'll be covering in future weeks. There's the one that springs to mind is about the effect of local winds, onshore or offshore, which ties into all of those. And that's why things in surfing are quite often quite hard to predict, and why there always is that real skill and real art to predicting surf, because there are so many different elements that go into it. You could have the perfect beach slope for the wave you're looking for. You know the perfect swell, but then the wind changes and it overrides them all and messes it all up. On the other hand, you can have the absolutely perfect beach and the perfect wind, but then you just get a swell that doesn't have the guts or the long period behind it to make the wave break in the way you want. But I think that's definitely sort of enough for this week in terms of sort of new concepts. And I hope you guys have got a bit of an idea of them. Because we've covered so much, I'm sure you guys have got lots of questions about how this relates to what you guys want from it and what you've seen in the past. There are no stupid questions, so please, there's only a few of us here. So use this as a chance to, if you're thinking it, someone else probably is as well. So just shout it out, and I'll try not to laugh if it is a really stupid question.
I've got a question. What are the swell periods you think are like wind chops, and which ones are going to be like bigger swells ones then?
In terms of the periods length. Yeah. So yeah. In the UK, generally sort of 7 seconds and below, we would definitely class as wind chop. Okay. That means that the storm's pretty close. It varies in different places around the world, depending on the kind of swells that they're regularly exposed to. But definitely in the UK, 7 seconds and below is kind of can be really wind choppy. Anything from sort of say 8 seconds through to 10, 11 is probably pretty average. But that's kind of what we're aiming for. That would be decent surf. We're pretty happy when it's within that range. Once you start getting to sort of 12, 13, 14 seconds and upwards, that's when it's going off the chain. They're those days where you might see on Magic Seaweed where it's saying, let's say, for example, 2 foot at 16 seconds, and you're looking at it going, oh, sweet, I've got a nice 2 foot swell. That's perfect for me. And you get down the beach and it's like head and a half and barreling. And that's the effect that longer period swell, so the faster moving waves can have. So I'd say those are your sort of 3 main categories of that sort of swell period if you're looking to plan your surf,
Yeah. Thank you.
Generally, from what I've seen, about 10 seconds, if the swell's coming in exactly the same direction, 10 seconds will mean that however high they predict the feet of the wave will be, is generally what it will be. Okay. I don't know if you'd agree with that, Del, but if it says
probably as a rough guide,
roughly 3 foot.
Yeah, if it said 3 foot at 10 seconds, you're on a lot of the beach. As I said, there's so many factors that go into it. But let's say you're going down Crantock or Fistral or something like that. A swell 3 foot at 10 seconds, you'll probably expect the waves to be somewhere around 3 foot. Mm-hmm. If you're going and it's 3 foot at 5 seconds, chances are it's probably going to be about knee high, something like that. That lower period reduces the power in the waves. On the other hand, if you've got 3 foot at 15, 16 seconds, it can be well overhead. Just that extra power and the speed that the waves are coming. going back to what we were talking about how the bottom of the wave slows down. The other thing to think about with the longer period swell, where they've got a longer wavelength, is not just that the wave could be the same height, but with that bigger wavelength, the wave is fatter. Okay, there's a lot more energy moving. The span of energy in that wave spreads much wider. Whereas a wind chop wave, it might, the period's only 5 seconds, but it might have a wavelength of only a couple of meters. The longer period swell, it could have a wavelength of sort of 20 meters or so, meaning that as the bottom of, if we're going like this, as the bottom of the wave jacks up, there's so much extra momentum coming in here behind it that not only does the wave throw, it also grows in size. Okay, because there's that mass of water all hitting the beach. The bottom of it has suddenly stopped. So it doesn't only move faster, it also means that the wave grows and gets taller as it hits that shallow water. And that's why the size of the wave can increase with the actual sort of the size of the wave on the face of it can increase a lot as the period jumps up as well.
So that makes for steeper waves then, doesn't it? Like really hard to...
Yeah, so longer period swell will generally give you steeper waves. What you find as well, I think, trying to think, from memory, last week, we talked about the how waves bend and wrap around obstacles. So like getting into Towan, for example, a westerly swell would have to bend and wrap to get in there. Longer period swells have much more of an ability to bend and focus in on beaches. So you'll find that, let's say we say the swell coming from exactly the same direction, it's exactly the same height. You've got a swell that's 3 foot.
Where's down?
Can you guys still hear us?
No, we're struggling a bit.
So I'll try to sit a bit closer. So if you've got a swell that's coming in at a normal angle for us, a westerly angle into Cornwall, 3 foot at 8 or 9 seconds, you might find that in at Towan, there's very little waves. It's pretty small. The waves don't have that power behind them to wrap and bend into the bay. Whereas a 3 foot swell at 16 seconds from exactly the same direction, it will have that power and the wavelength behind it to bend around and make its way into Towan. So even though the swell height isn't necessarily bigger, that extra period will mean that it wraps into the more sheltered bays a lot easier as well.
Okay.
Anyone else? Don't all jump at once.
It may, like when the swell period is really far, sort of like 15 or 16 seconds.
Yeah.
Do you have? I really struggle in. It might be my crap paddling, but do you have any techniques or advice about paddling into those kind of waves? Because I really, really struggle. Like when obviously you say, like the big,
sure.
As you said, the waves are quite a lot fatter and
So that's something that everyone will have experienced.
Okay.
When going back to when we were talking about wave period and why it happens, about the wavelength and that it's traveling faster. If a wave's traveling faster, it means you have to get your surfboard traveling faster in order to catch it. So that's why when those waves are bigger and more powerful, you feel like you're paddling the same as you would on your normal day at a beach. And the wave just goes underneath you, or you're stuck at the last minute on top of it going, that's why that sort of paddle strength is so important and altering your paddling depending on the waves. If you've got a really big period swell, you cannot cruise into any wave.
Okay.
There's no way that you're going, this one's going to be easy to get. I'll just do a couple of paddles and I'll be in. Watch any professional surfer, and even not even professional, even decent level surfer. And when you're out on those really big, long period days, everyone is kicking and scratching as hard as they can to get into them. It's full sprint for every single wave. It's very difficult to get a roll in or anything like that.
Yeah.
The only people you will see catching waves like that where it looks like they're hardly paddling are generally the people who are happier taking off on a much steeper, much more critical phase. If you're happy to take that super late drop and airdrop in, then absolutely, you can maybe pop and go 2 or 3 paddles and you're into it. If you want to be having a nice smooth entry, which I'm assuming everyone here does, you just got to put the extra time in. You just got to start paddling earlier, make sure that you really going full speed, and that by the time the wave is reaching you, you're paddling as fast as you can. Also, going back to what I was saying about how the waves can be much wider, whereas on a normal day, you'd paddle in, you'd feel the wave start to pick you up, and you're like, okay, I know if I take another couple of paddles here, I'm in, I can get to my feet. Because the wave is much longer, the wavelength's much longer. From that point where you feel the waves start to pick you up, where you would normally go, right, couple more paddles and I'm in, that you might need another 5 or 6 paddles to get in that full swing. At the point where you think you're into it, you stand up then, you're still not even anywhere near it, and the wave's just going to sort of bobble under you.
Okay, thanks, mate. So it's me not adjusting my epicness, basically.
Yeah, crank up that epic scale, Claire. That's what we need.
Right.
Or just airdrop.
Thank you.
Yeah. Into it. No, it's something that everyone goes to, and you'll see on those really like picture perfect swells. If you ever look out at a lineup, or if you're out there, look around at other surfers. Even though the waves look absolutely perfect, there are far few people actually catching waves. There might be a lot more in the water, but if you look around on days like that, it tends to be the best surfers who are the ones catching waves. And you look around and you see everyone buzzing around, but watch how many other people paddle for a wave and miss it. And it's all down to that. Just you really have to up your game. As the waves bring more power, you need to bring more energy to it as well. Paddle harder, paddle faster into that wave.
All right, mate. Thank you.
Also means you have to paddle harder to get out through them.
Well, but that's the benefit of those longer period swells, is that because they're more organised, yes, the waves when they come are bigger, they've got more power, they're much more fun to ride, but they're also much harder to get through if you get caught inside. They're fine. So you've got sets and you've got lulls. It's not like those wind choppy onshore days when you just feel like you're constantly paddling and getting battered from every angle. If you've got 16 seconds between each wave, that means you duck dive it or turtle roll or whatever. You've got time to get through it, recover your board, really make some ground before the next wave. If you time it right, you can very easily get out on a day that, say you're wanting to push your limits. And I think for most of you guys here, you guys are all pretty comfortable in the sort of when it's waist to chest high day. But let's say you want to push your limits and you want to go out when it's more like head high, go out on head high day when it's long period, because you'll have those lulls. You can paddle out there, you can sit, you can watch the waves. They're a lot more organized and you can start to understand them. Yes, when you go for them, you're going to have to put a lot more effort in, but because you've hopefully, if you've planned it right, had a much easier journey on the way out, you've also had the time to be able to sit there, watch what other people are doing, watch where they're sitting, and plan what you do, rather than those sort of messy wind choppy days where, well done, you've made it out, and then you're like, oh crap, there's one there, and then that one's breaking there, and you don't know which is a good wave, which is a bad wave. It's all happening so quickly on those longer period days. Now, I'm not saying go out sort of out of your comfort zone too much, because obviously with a lot more powerful waves, you don't want to end up with a wave in your head or getting yourself into difficulty. But just to sort of within your range, just push that comfort zone a little bit. Those longer period days are the ones to go for. Has anyone else got any questions?
Just with those bigger waves and the paddling, what sorts of things could we do to just get better at paddling? Is there like a magic trick or something?
Unfortunately, there's no real magic trick and shortcuts. There are certainly exercises that will help you, but there is no substitute for just getting in the water and paddling.
Right.
That's kind of why me and Ross have both been trying to say that every week, really, it doesn't really matter on the conditions that are at the beach. Obviously, right now it's not possible with the lockdown and everything. But in general terms, when we're looking week on week, what we're doing with the hello. You want to come say hello to everyone? No, it's exciting. You heard me talking. All right. So yeah, week on week, even if it's horrible, it's blown out, it's onshore, getting in the water and paddling, learning how to paddle through waves. If it's not safe to be out in the waves, getting in the gannel, and literally just, we can do some paddle drills, work on you guys like paddling up and down. If you can't be getting in there, getting in the swimming pool is really good. Just general time in the water. One thing that really helps is doing, I don't know if you guys have ever seen it, but like water polo stroke, where basically you're arching your head up, you're trying to keep your head out of the water and doing front crawl, because your back will be arched in a very similar curve to how it would be when you're lying on a surfboard. So the muscles that you use are very similar.
Okay.
There's also plenty of exercises online that you can find to help surfers with paddling, like dry land exercises, different bits of yoga. The key to, in my experience, like this is just my personal opinion on this, I think that the secret to good paddling is a lot more to do with technique than strength. There are a lot of very physically strong people, and even people who are very good swimmers. I've had triathletes come down and things like that, who you lay them on the board and in a swimming pool, they might be able to outswim you easily. They're super fit, but you get them on a board, and because it's very slightly different muscles, it's all the small interconnecting muscles through your shoulders, through your back, that are the key. Also, how you're moving your hand through the water. They're all the things that decide how fast you paddle. So as much as there are a lot of other exercises that can help paddling, when we have customers through the surf school that are coming down from up country, I point them in the direction of dry land training and this and that, and get into the pool. You guys will live by the coast. Get in the water, get on your boards and paddle as much as you possibly can. And the better you are at paddling, the better you will be at surfing. People put a lot of time and effort and also thought and worry and everything into improving their surfing technique. If you can get better at paddling, it means you catch more waves, which means everything else naturally gets better because you're practicing it more. It means you don't get caught inside as much, because when you do get a lull and you can get out there, if you're faster at paddling, you get out there quicker, which means you don't spend as much time getting pummeled by the white water, which, even though I don't mind it, some people do mind it, none of us would choose it over catching a wave and riding it. So it ultimately means you get to do more of the fun bit of surfing. So for those of you that live around the beach, and everyone here does, in Cornwall, we're so lucky, there's always a place where you can go take your board and just go for a paddle. And there really is no substitute for it. And next time we're allowed back in and we get a sort of conditions where it's not ideal for us to be doing the surf club, actually going and catching waves, either it's too flat or it's a bit too wild and stormy and we want to stick to more sheltered waters. Me and Russell try to go through like a bit of paddling technique, run through a few paddle drills that you guys can just do. There's a high tide every day on the Gannel, and certainly maybe it's a bit far for you, Claire and Alyssa, but for most of it, there's always going to be somewhere where you can jump on your board and go for a paddle. And if you're working on that technique, thinking about how you're moving through the water, it will make such a difference when you next get back in.
Cool. Awesome. Thank you.
Anyone else?
Going back to the paddling technique, generally, the closer your hands are to the rails of your board, the faster you're going to be paddling, or the more efficient each paddle stroke will be. If your hands are really wide out and far away from your board, you're doing more turning than you are going in a straight line. So your paddle strokes aren't going to be aiming you where you want to go.
Okay.
Good tip.
What would when you said about how you move your hands through the water when you're paddling, what would you do? Because I've been told to sort of almost do like a polar bear paddle, so you kind of almost go underneath the board a little bit.
Yeah, that's what I do. Hand in at the front of the nose of your board. If you're on a short board, it's usually around the nose of your board. When you're on a longer board, it's basically stretching as far as you can there. I don't know if you can see that in the camera. With my arm locked down, I don't have a lot of strength there to pull back in. It's not until you get to the point where your arm's a bit bent. That's your peak power zone here. So you don't want to reach too far in front. Hand in the water, pull it back. As soon as try and keep high elbows. As soon as you can get your hand behind your elbow, that paddle stroke isn't a pull, it's a push. And your body has got a lot more power naturally, the way that your muscles line up, a lot more power pushing than it has pulling. So keep your elbows nice and high. As I say, scoop under the board is good. The reason why that's good, I don't know how this will work, but try to show you from the side. If I'm just paddling straight like that, all I'm using is my forearm here. By scooping under the board, you can see there I'm getting my elbow in front of my hand, so that then becomes a pushing motion. And it's using all the muscles across that side of your chest, that side of your shoulder, all the way down your back. There's basically a lot more muscles working to do the same action, rather than just you pulling there. Unless you've got sort of giant Popeye forearms, you're going to really struggle to get much speed out of your paddles there.
Cool.
When you're all the way out to the back and pushing it, like keep that push going. But again, don't worry about overextending there. In technical terms, it's the cadence that you're looking for, which is the number of strokes that you're doing. So keeping that rhythm going and getting those arms moving around in your sort of in your power zone of your paddling, that's what's going to get you going nice and fast. Yeah, that's going to be the key. I don't want you to take that the other way and end up doing these little like rabbit paddles. So we don't want any of that, but you do still want a nice decent length of paddle. But the more important thing is that where you're paddling is in that power zone where your body's working with you. But we'll go through that next time we're in the water. We will go through a lot on paddling with you guys.
Cool.
One thing I meant to mention, if any of you guys, this sort of wave theory stuff, if you are actually interested in knowing more about it, I would highly recommend that book. I don't know if you guys can see that. It's just called Surf Science. It's by two surfers who are both also doctors. They both put their time in really big waves as well. So they understand it from a surfer's point of view and also from a scientist's point of view. And unlike a lot of other books that I've come across on sort of oceanography and wave dynamics, they explain everything in quite a understandable way. It does get technical. They do cover really quite complex scientific theory in there, but they do it in, well, for want of a better word, normal speech. Okay, they're not getting too much into the technical terms, and if they are, they explain them. If you do want to know, if anyone is really familiar with maths or science and want to look in deeper, in and amongst it, they do little pop-up boxes there that will explain the equations and the theories and everything behind it. But what's important to make it accessible is that you can read the whole thing while ignoring all that technical side and still get a pretty good understanding of what's happening. And that will go through everything from the creation of storm systems and why, with pressure differential and with how the sun heats up certain areas of the earth more than others and why wind patterns form, right the way through creation of waves, everything we've gone through today, waves reaching the beach, goes through differences between point breaks, reefs, beach breaks and how the waves bend and move around them, rip currents, even goes into tides, everything like that. A lot of the stuff that we'll talk about, not just today and last week, but through all these theory sessions, my basic theory is all sort of, I based it on that book and just tried to sort of make it a little bit more accessible for everyone and relate it to what we experience here in Cornwall. So yeah, if anyone finds this stuff pretty interesting, then that would definitely be the book to go for.
Cool.